Greetings, and welcome to another OutSystems how-to video. My name is Andrew Duthie, and in this video, I'll show you how you can create an internet-connected, AI-powered candy dispenser. Let's get started. This video starts with a story. A few weeks ago, I was preparing for a presentation at a local code camp, a technology event for developers. In preparation for that, I had asked my manager to send me some items, including some Hue light bulbs for my demonstration, which was to be kind of a demo of a day in the life of a developer using IoT and an OutSystems mobile application. What also came in the box surprised me a bit. One of the things in the box was this item, a plastic handle, which I wasn't quite sure what it was for. Another item included was this. For those of you who haven't seen one, this is a stepper motor. A stepper motor is an electronically controlled motor that can be moved in discrete steps with great precision. These items confused me at first until I remembered that he had asked me a while back if I could create an adapter for him from this item, which is a handle, to this item, the stepper motor, all in service of driving this. So for those of you who haven't seen one, this is a dispenser that's typically seen, for example, at hotels in the kitchen area for dispensing things like cereal or other food items that are kind of small and discreet. And he had thought that it would be fun to create a candy dispenser that could be controlled with a stepper motor. Now, I started working on this and came up with an adapter for the motor shaft to the handle fairly quickly. And you can see the handle in the picture here, which drives a paddle wheel that dispenses the item that's in the hopper above. So I was able to create the handle adapter pretty quickly, but the problem was that without the dispenser, I couldn't really tell whether the dispenser would work with the stepper motor or not. So, of course, I had to build the item myself. So I ordered one of these dispensers and then created an electronics rig to drive the stepper motor. That rig looks like this. So what you see here is a breadboard, which is an electronic item that allows you to plug various wires in and connect them. There's a microcontroller board on here that's called a particle Photon. You'll see a better image of that here shortly. A stepper motor driver board, a button, and then also some wires to connect up power and such. The board, which you can see here a little more clearly that I'm using, again, that's called a particle Photon. It's about a $20 internet-connected programmable board. So it's a microcontroller board, makes it very easy to control digital and analog pins, to read sensors, to send outputs, etc. So a very nice way to control something like this. Then you can see here, this is a driver board. This is called a TB6612, and it is a chip that allows you to easily control stepper motors. If you look on the bottom of that, there's a black and white wire coming out. That's for a 12-volt power supply that actually supplies power to the driver, or the to the driver board, which then provides power to the stepper motor. And then there are 4 wires that come out the side that go to the stepper itself to control how it steps. Next, let's take a look at the code that drives all this. As I mentioned before, the particle Photon board that I'm using to drive the stepper motor is an Arduino-based board. That is, it can be programmed with the Arduino language, or IDE, which is actually a C++ language. And in this case, I'm using Visual Studio Code to do the programming. There's actually an add-in for Visual Studio Code that makes it very easy to upload your code to the particle Photon board either locally or via the particle cloud, which is a convenient way of programming these devices. The actual code that drives the entire project includes both a library for driving the stepper motor, as well as a library for some LEDs that I've got connected to help me understand status information if for some reason the stepper motor isn't working properly. I can at least understand from the LEDs what's happening when I send a command. it also includes a library for the particle board itself. So not going to go too deeply into the code, but pretty straightforward here. I have at the bottom of my code, I have some functions that are related to the LED. For example, I'm going to do a color wipe. I have an LED ring for my status, and we'll see that in a second here when I demo. But basically, I'm running through a series of LEDs and setting the colors depending on what color is passed into the function. I can also have some helper functions for setting the step count, the step speed, releasing the stepper motors so that they're not trying to drive when they're not moving, and then some helper functions for no candy, meaning, well, we're actually not going to dispense anything, and then also for dispensing. And then I have a function for stepping, go step, that's going to figure out or pass a message out to the particle cloud saying that we're stepping. That allows us to log some information. We're going to call into the stepper library and pass the number of steps, and then we're going to release the stepper motors. And then the last thing we're doing is, as in any Arduino, we have a setup phase and a loop phase. If you've used Arduino Code before, you're probably familiar with this, but in setup is where I set things like the mode for the various pins that I'm using for my input or output, and also configuring my stepper motor information here. I have a few initialization steps up here, and then I'm setting up, in this case, some variables and functions in the particle cloud that correspond to various variables and functions inside my code. So we saw these functions below. Then I'm going to simply initialize my LED ring, set the brightness, and do a color wipe of blue to indicate that our initialization is complete, and then show that color wipe on my LED ring. And then once I've actually finished preparing my application, I'm going to publish out to the cloud, particle cloud, the setup complete log. In the loop, I'm going to go out and read the state of the button switch. I'm actually not going to use the button for this demo, but I left that in there for purposes of testing locally. And importantly, what I'm going to do is, if I have a reading from the button, I'm going to go ahead and change the button state, or publish that the button state changed, and do a dispense. Again, I'm not going to test this code specifically. Now, because I set up these functions, the dispense and the nope, those are actually going to be available to me through the cloud to call into my device. So simply by calling particle function and having the corresponding code here, dispense candy and no candy, I can call from the cloud into my device using a simple REST API. So one of the other things that's useful about the particle Photon is they actually have an entire cloud infrastructure that for the first, I think, 100 devices is completely free to use. So it allows me to very easily connect my board to a Wi-Fi source. In this case, I'm using my cell phone as a hotspot, and get this board connected to the internet very easily. When I'm connected to the internet, I can take a look at the events. So when you saw the code that did a particle.publish, it's actually sending information to this event log. Likewise, I can scroll down here and view the functions and variables that are available on my device. So if I wanted to manually just call into the functions for dispense, nope, etc., on my device, I can call those with the desired arguments directly from the particle cloud. The last important piece here is, of course, the OutSystems application. So I've created an OutSystems mobile application with several screens that allow me to interact with my device. One of these is using NFC, or near field communications. So I have an NFC plugin that's a simple mobile application plugin that I can just drag and drop onto my screen, and then set up a handler for read events when the device detects that an NFC tag is nearby and can be read. And inside that, I'm going to call and find to see if the records match the data that I expect to see for the code camp presentation that I'd put together. If I don't find that information, I'm going to call a server action I created called fail. We'll take a look at that in a minute. Otherwise, I'm going to call a server action called dispense. Either way, I'm going to provide some feedback message to the user, so either no match or tag match in dispensing candy. I can also use sentiment analysis from Azure Cognitive Services. So in my AI sentiment, I have a simple text box. I can paste in some text. That could be a review or a tweet or something like that. And when I click Analyze, I'm going to run a client action that's going to use, again, a plugin called Detect Sentiment in Text. And that's just an AI plugin that's wrapping Azure Cognitive Services. And it's going to provide me back a sentiment score. And if that sentiment score is greater than 0.5 or 50%, then I'm going to dispense candy. Otherwise, I'm going to call the fail action and again send status messages. Now, the cool thing here is that this AI plugin I configure once. So I've created in Azure an instance of Azure Cognitive Services. I've gotten the appropriate key, and then I've added that key to the configuration for my plugin. I do that once for my environment, and then I can use this AI widget anywhere in my application. I don't have to worry about the configuration. It just works. Last but not least, I have a screen that's going to check my mood. So that screen is actually going to use the camera plugin. And when I tap on the image that you see here, I'm going to run my on click. I'm going to check for the camera plugin and display a message if the camera isn't available. I'm going to attempt to take a picture and then use the face detection portion of Azure Cognitive Services to detect a face and then attempt to detect the emotion on that person's face in that photo. So I'm going to return some information just for debug purposes based on what percentage of anger are we seeing, what percentage of happiness, what percentage of sadness. And then I'm going to do some analysis. So is unhappy is a condition where I'm going to say, is anger greater than 0.25 or is sadness greater than 0.25? If this person's unhappy, then, well, we kind of assume that they're unhappy, that candy will probably help with that. So we'll dispense some candy and we'll mark the end. So is unhappy is going to detect anger of greater than 0.25 or sadness of greater than 0.25. We'll do some assigns to show the appropriate image. We're going to show the angry picture. We're going to hide the neutral and happy picture. And then we're going to send a message and dispense some candy. If they're not unhappy, then we want to see if they're happy, which we're looking for happiness of greater than 0.5. In this case, we're going to hide the show neutral, show the happy image, and hide the angry image. And if you're happy, you probably don't need candy, so we'll run the fail server action and end our flow. Now let's take a look at how all this ties into the actual IoT board itself. In my server actions, I have a dispense server action. Let's take a look at that. That's calling into this dispense candy action. That dispense candy action is simply a call to a REST API. And that REST API has a URL path. It's calling via post, and it's passing in an access token that I have gotten from my particle board itself. Similarly, the nope action is going to call the API endpoint for my particle of nope and likewise pass in an access token. And then that access token I simply pass in as a token argument when I call the dispense candy REST API endpoint from my server action. So my dispense server action calls into the dispense candy REST API and passes in the appropriate access token. Right, that allows me to access that function and call into my device. So enough talk about how the project's put together. Let's take a look at it in action. On the screen here on the left, what you're seeing is a webcam that's pointing at the candy dispenser. You'll see prominent front and center is our Neo mascot. That's a 3D printed Neo that I've got attached to the front of the stepper motor. So if you look here, this is the stepper motor. Attaching the stepper motor to the dispenser is a custom 3D printed bracket that I designed and printed. And then inside, which you can't see from here, is the adapter from the stepper motor shaft to the dispenser paddle wheel. And of course, the dispenser's full of M&M's candy. For those of you outside of the United States who don't think M&M's are candy, that's fine. You can fill the dispenser with whatever candy you might like. Underneath the dispenser, I have a cup to capture the dispenser. And then I have a USB cable connected to my particle Photon device and a battery pack, USB battery pack to run the Photon. The device is connected to a 12-volt power supply that supplies power to the stepper motor. So I'm going to go ahead and plug in the device and turn on the battery pack. And we should shortly see a blue ring of light that indicates that the Photon has been initialized and has connected to Wi-Fi successfully. So now we're ready to command our device. On the right side of the screen, you'll see a projection of my mobile phone, and I'm going to use this to run the OutSystems mobile application. So as I mentioned, this dot here on the side of the device is an NFC tag. That NFC tag is also programmed to launch the application on my device. So if I tap my device on the NFC tag, it's going to go ahead and launch the IoT application. And the first thing we'll demonstrate is the text sentiment analysis. So I'm going to type in a very simple comment, boo, as in boo hiss, bad thing, and I'll analyze that comment. And we'll see we get a red color wipe on our LED ring, which is behind the 3D printed Neo, and I get the message no winner this time. Let's do a similarly simple text message. We'll say yay, hooray, and we get candy, and we get a nice green ring. So terrific. So we know that this is working now. Now again, this phone is not connected directly to the device. It is using the REST API connection that I set up to call out to the particle cloud, and then the particle cloud is in turn calling the function on the device to dispense the candy. All right, let's try our NFC next. So with our NFC, again, we're using an NFC plugin from the Forge open source library. Very simple to use, just drag and drop. In addition to the NFC tag on the dispenser itself, I also have a card that has another NFC tag that does not have the required text information to dispense candy. So I'm going to take and swipe that on the device, and you'll see that it gives me the no indication on the ring to indicate that, hey, this is not the right card. Now, if I take the same screen and swipe it against the tag on the device, we get the green ring and we get the tag matches and we're dispensing candy. So far, so good. Just going to empty my candy there so I don't overflow my cup. And then last but not least, let's do a check of my mood. And you'll have to forgive my background. My office is a little bit messy here. So I'm going to check the mood detector, do a selfie. So I'm going to give it a smile. Check that. It says happy people don't need candy, and we get the red ring. So now we're going to see if I can come up with a really nice angry look. Oh, and I need candy, so we'll go ahead and dispense that candy, and we're good to go. So I hope you enjoyed that demo. Just to recap, what we saw was the use of an Arduino-programmable microcontroller board and a stepper motor to control a physical piece of hardware and dispense candy over the internet. By using a simple $20 Wi-Fi connected board, we got internet connectivity. By leveraging the programmable cloud platform that the particle Photon provides, we are able to very easily REST enable our hardware device, and then leverage that REST connection from an OutSystems application to control the hardware from a mobile application. By leveraging Azure Cognitive Services and other plugins available in the Forge, we are able to very easily build up an application that could do complicated text sentiment analysis, mobile face detection and emotion recognition, as well as NFC support, all without writing a single line of code. Thanks for watching this video, and we'll see you next time.